All right, welcome America, welcome Taylor Swift. Today we just finished reviewing the unit circle, and we have just had an introduction to the unit circle, so this is all new and fresh, and so we're gonna go really slowly, and we're gonna go ahead and fill out the basic values for sine, cosine, tangent, cosecant, secant, and cotangent in this chart, and I hope to finish the whole chart. We'll see how long it takes and how much we can get through in our video. So first thing I'd like to do is draw these angles and get an idea for what the angles look like, right? So when I start each of these, I'm trying to find the sine or the cosine or whatever trig function of a certain angle. I figure out in my head, all right, where is that angle? And right here, that's 0 degrees, right? We haven't gone around the circle. We've gone around 360 times. We're starting at 0 right there. There's your turn on the side of your angle. Pi over 6 is the short triangle, right? The short angle. So when I draw those, I just do my best to kind of represent a short angle. And the pi over 3 is the tall angle. So when I do that, I kind of just do, you're breaking that quadrant up into thirds. So kind of draw that as tall. And pi over 4, that's the middle angle. So I just do my best to draw that right in the middle there. And pi over 2 is up here. All right, so now we need to think of the unit circle when we're filling these in. So the sine of 0 degrees, when we are working with, when we're starting with sine, the sine are the y values. So at that point, 0, 0, what is the, if that was an, it's gonna be too small, right? The ordered pair for that point is on the circle, right? All these are on the circle. That ordered pair is at 1, 0, and I'll erase this, but it's at 1, 0. The x coordinate is 1, the y coordinate is 0. So when you're asked to find the sine of this angle, you need the y value. The y value is 0, so the sine of 0 is just 0. Now let's go to this point up here. This coordinate, if I was just plotting that point, and this is on the circle right here, the x coordinate is 0 and the y coordinate is 1. So this is 0, 1, right? So now what would then the sine of pi over 2 then be? Because we're looking for the y value. So that ordered pair is 0, 1. What's the y value for that ordered pair?
1.
So it's just the sine of pi over 2 is 1. Now we're going to use the values that we just worked on when we were filling in the unit circle for the other ones. The first one we did was pi over 6. That's a short angle, right? We've represented it right here. The x distance is longer than the y distance. And the two numbers that we are working with are root 3 over 2 and 1/2. The middle angle values are root 2 over 2 and root 2 over 2. Those are the same. We don't have to worry about those. But of these values, which one is the bigger number? Is root 3 over 2 bigger or 1 over 2? Which one is the larger fraction?
3 over 2.
How do we know root 3 over 2 is larger? You're right.
It's more than 1.
Root 3 is 1 point and some stuff. So this fraction right here is larger than 1/2. If you put it in your calculator, it's going to be a larger number. So since the x distance is longer than the y distance, the x distance is root 3 over 2 for this point, and the y distance is 1/2. We're asked to find the sine or the y distance. So what's the y distance? So what's the sine of pi over 6? We need the y value. 1/2. Pi over 3 is going to be the opposite because the x distance is shorter than the y distance. So the sine of pi over 3 will be what? These two numbers have been switched.
Root 3 over 2.
So that's going to be root 3 over 2. The x coordinate and the y coordinate for the sine of pi over 4 are the same, and they're both root 2 over 2. And we found those values using the special right triangles. So whichever one we're doing, doesn't matter, that's just root 2 over 2. And it's going to be the same for cosine. Now, when we get to our cosine values, okay, if we are looking at the short angle versus the tall angle, we're dealing with the same angles, but now cosine is asking for the x coordinate rather than the y coordinate. So these numbers will be switched. So the cosine of pi over 6, or the cosine of the small angle, we're asking for the x distance. The x distance is longer than the y distance. So this is root 3 over 2. And this one is 1/2. These values are also switched because at 0 degrees, cosine is the x distance. The x distance is 1. So the cosine of 0 is 1. And the cosine of pi over 2, that ordered pair is 0, 1, and we're looking for the x distance. Cosine of pi over 2 is 0. How are we doing? I know it's a lot. I know it's a lot. The tangent, those are the values I asked you to memorize. Because we don't want to divide two fractions every single time. I think the easiest way to memorize this is the values are, the ones that people get confused are root 3 over 3 and root 3, okay? And the two angles are the short angles and the tall angles. The short angle, this is a smaller angle than the tall angle, right? This is 30 degrees, that's 60 degrees. Same goes for the two values that you have to memorize, root 3 over 3 and root 3, which is a smaller number.
Root 3 over 3.
Why? Why is root 3 over 3 smaller than root 3?
Because you're dividing it by 3.
Yeah, we're taking a number that's bigger than 1 and we're dividing it by 3. So this is the smaller value. It's going to go with the smaller angle. So the tangent of the smaller angle is root 3 over 3 and the taller angle is root 3. Now what happens at 0? Remember the ordered pair here is 1, 0. And the tangent is y over x, or opposite over adjacent. So y over x, 0 over 1 is just going to be what? 0. What happens when I switch those values? 0, 1, and I put y over x. The tangent of, and this is pi over 2, is going to be 1 over 0. What is that? Undefined. We kind of went through that when we were doing the unit circle. So this is undefined. The last one here that I haven't filled in is the tangent of a middle angle. The x value and the y value at that ordered pair are the same. So it's root 2 over 2 over root 2 over 2. Anytime you take a number and put it over itself, you're going to get 1. So the tangent of pi over 4 is just 1. How am I doing? Is this super exciting yet? Did you guys like the call from my niece who said how important this was in life?
Yes.
Yeah. I'll tell you more about her later. Okay, so now we have to also remember that the cosecant, and the cosecant is the reciprocal of sine. So this is equal to 1 over sine of theta. And theta is just an angle. They usually use theta, but they can use any variable there. The secant is equal to 1 over the cosine. And the cotangent is 1 over the tangent. So all these values are now just going to be flipped. And we're going to put 1 over these numbers. So instead of putting 1 over a fraction, we do keep, change, flip. That fraction, for example, well, let's just start with 0. This 0 is 0 Okay, so if I take 1 and I put 1 over 0, what's going to happen?
Undefined.
Undefined. Okay, if I take 1 and I put it over 1/2, we don't have to go through all that. That's just going to be keep, change, flip. The 1/2 is going to flip, and that's just going to become a 2. Now, this would be 2 over root 2. However, we don't write 2 over root 2. With a radical in the denominator, it has to be rationalized. So we have to multiply by root 2 over 2 over root 2 over 2. So our denominator becomes 2, and our numerator is 2 root 2. And then the 2's cancel. So this just becomes root 2.
So is it 1 over 2 root 2?
Say that again?
So is it 1 over 2 over root 2?
No, it would have been the reciprocal of this one. So it would have been 2 over root 2.
Oh, okay.
But we can't leave it like that. So we had to rationalize it by multiplying by special 1.
Okay.
And in doing that, we ended up with 2 root 2 over 2, and the 2's canceled, so it's just root 2. So instead of writing it this way, we write it like this. Same thing happens with 2 over root 3. We can't leave it as 2 over root 3. We have to rationalize it. 2 over root 3 by root 3 over root 3. And that becomes 2 root 3 over 3, which can't be simplified, so we just leave it as 2 root 3 over 3. Now, what's going to happen with the 1?
Zero.
If I take 1 and put it in the denominator of this fraction, 1 over 1, what's that?
Oh, 1.
So it's just 1. How far have we gotten? Oh, this is already 12 minutes. I'm going to stop. I know. Sorry, America.